but still I did not get the link of your try to sit with a calculator. It will be helpful for you to understand this class if you sit with a calculator. I think it will be better if I write the example on the next page. Take some space.
So what have you written? Added to the
Minuen, M-I-N-U-E-N-D.
okay.
Okay, so let's start with subtraction of unsigned numbers. We have already discussed what is unsigned numbers, so I will not go over there. The thing that we need to focus for the time being is on the syntax. So the syntax is SUBB, and your destination must always be the accumulator. You cannot have any other register in place of A or accumulator. And source can be anything, other registers, memory location, direct value, everything can be there. Okay. So what happens when you write sub A comma source? It actually does is A minus source minus carry flag. Okay. So this is what actually happens when you write sub A comma source. So as you understand, there can be two scenarios. One is when your value of your carry flag is 0 or when the value of carry flag is 1. So first of all, let us see what happens when the value of carry is equal to 0. These three steps that you see, it is not that you have to perform these steps. These steps are normally performed by your MuC whenever your MuC encounters this sub instruction. These three are basically the steps of sub instruction. So although you don't have to do this, but you must know what happens when you write sub. So it will help you. Anyway, I will explain these 3 points with the help of an example. So if you have any question at this stage, keep it with you. Let me finish the example, then I will let you ask your questions. So the question is, add 4CH, sorry, not add. So the question is, that very simple, right? Nothing complicated. So subtract 6EH from 4CH. You simply clear your carry first of all. Then you move the first value, I mean the number from where you need to subtract. You move the first value to A, then sub X. So 4C minus 6E minus carry will be performed, but carry is 0. Then the result will be stored in the accumulator. So you finally transfer the result to R1. Now let us break it down and try to see what is actually happening. Okay. So as I said, try to see to the calculator. So if we perform this operation, 4C and 6E all are definitely in hex. So if we subtract, we'll try to find the result. But before that, let us do it in some other way. Someone tell me what is the binary equivalent of 4C? What is the binary equivalent of 4C?
1001100.
Is that so? The binary equivalent of 4C?
Yes, sir.
Yes, sir, it is.
0100, isn't it? Always say in 8-bit format. That's why I got confused. 1100, right?
Yes, sir.
Yes, sir.
Fine. Then we need to subtract this one. So if you find a negative number, what you will do, you will take the 2's complement of the, okay, anyway, so we are subtracting. So the first thing is we need to find the 2's complement of the subtrahend. So which one is the subtrahend over here? 4C or 6E? Which one is the subtrahend?
6C.
Exactly, 6E. See, it is bracket. In the bracket, it is also written source operand. Okay. So this one is your source operand. So now we need to find the, according to this instruction, first of all, we need to find the 2's complement of the subtrahend. So tell me what is the 2's complement of 6E? The 2's complement of 6E. Please try to do it. Okay, it will help you. This is-
1001.
Yeah, 1001.
1001.
Then
0001.
I don't think so. It should be 0010. Just check.
Sir, 1001 0010.
Yeah.
Yes, sir.
So this one. All right. So what we have done, first of all, we have taken the 2's complement. We're done with that. Then we need to add it to the minuend. That is whatever is there in register A. So we'll perform this addition now. So let us add. So if we add, the result will be 0 plus 0 is 0, 1 plus 0, 1, 1, 1, again 1, 0 plus 0 is 1, 0, 1, 1, 1. All right. Now, so we are done with this second step as well, right? we have added it to the minuend. Now the third step says invert the carry. Do we have a carry over here? Is there any carry?
No, sir.
So if there is no carry, can we write that the carry is 0?
Yes, sir.
Okay. So according to the last step, we need to invert the carry. So if I invert the carry, my result will be 1, 1, 1, 0, 1, 1, 1, 1, 0. So we are done with this 3 step. First of all, we have taken the 2's complement, we have added it to the minuend, and then we have inverted the carry. So then this is supposed to be your answer. This is your answer. This is the carry. So the carry signifies that this is a negative number, isn't it? The result is negative, right?
Yes, sir.
All right. So we write a negative for this. And what is the hexadecimal form of this 11011110? In hexadecimal, if you convert this to hexadecimal, how much do you get?
DE.
DE. All right. That means the result that you are supposed to get is something like this: FDE. Someone just use your calculator and check whether you get this answer or not.
Yes, sir.
All right. So you have got this answer. Now let us see whether the answer that we have received is right or wrong. Now tell me, what is the decimal format of 4CH? Convert it to decimal and tell me how much is that?
Sir, 76.
76. And how much is 6EH in decimal?
Sir, 110.
110. All right. Now, if we subtract it in decimal format, what is the result we get in decimal format?
Minus 34.
Minus 34. That is in decimal. All right. So minus is minus, nothing over there. If you convert 34 decimal into hex, how much do you get?
$22.
22. So now you see the problem. The answer that we actually expect is minus 22H, but even your calculator is giving you this answer. According to our steps, we also got this answer. So now tell me, which one is right and which one is wrong? At least tell me that you understood the problem we are facing. Have you understood the problem that you are facing?
Yes, sir.
Okay. So now tell me which one is right or which one is wrong, or whatever we have done so far, everything is logical. So where is the mistake?
Sir, the 8-bit is usually the sign bit, sir. Is that the case?
No, that is not the case. We are already doing sub, right?
No, if the negative decimal should be directly converted to negative hexadecimal.
Yeah, we just converted. Your sign will remain as it is, isn't it? Whether you go for hexa or decimal system, sign is sign, negative is negative. So we have just converted the number. Even from a normal point of view, this is the answer that you should get, isn't it? Minus 22H. You are not supposed to get FFFFD. Try to convert this into decimal and see. That is not the result that you expect.
Sir, the answer is in 2's complement.
Exactly, right. Very good. The answer is in 2's complement. That is what I was looking for. Okay. Whenever your result is negative, your microcontroller or your microprocessor always gives you the result in 2's complement. Okay. Always keep it in mind. So your calculator is nothing but a mu c. So definitely the result that your calculator is giving is in 2's complement. All right. So let's find out what is the actual result of this. So if it is in 2's complement, we need to convert it. So how can we convert it? So first of all, reverse every bit. So 1101 becomes 0010 0001. Isn't it? Then add another one with this. So if I add, how much do I get? 1 plus 1 is 0, 1, 0, 0, 0, 1, 0, 0. And this minus will remain as minus. So don't worry about that. Let that be minus. So now tell me, what is the hexadecimal format of this one?
22.
22. So that means, see, I have left some space over here, because if there is no carry, you have nothing to worry, okay? It will be as it is. But if we have a carry, then what we have to do? We have to complement the register, and then we have to increment the same register. And that is how you get the exact answer, which is supposed to be minus 22H. Is this portion clear to all of you? That's why I told you that see to the calculator. So see, even we need to know how the results are being displayed in a calculator, although we can use it. So your calculator will also give you the result in 2's complement. Now, in your exam, okay,
Sir, from minus 22, sir.
Bolo.
Sir,
Someone
from
was
minus
saying-
22, sir. Can you repeat the part again?
minus 22. Okay, so if your result is negative, the result will be displayed by your mu c in 2's complement. So if you want, you can change it back to the original answer. I mean, over here the original answer should be minus 22H, but the answer we got is FFFDE. So what we can do, if there is a carry, we already know that this is a negative number. So if there is a carry, we will manually find the 2's complement of this, which will give us our actual answer. And these two lines will actually find the 2's complement, and in that way your accumulator will contain the real answer. All right, so what I was saying is that if you face questions like this during the exam where you have to code, in most of your codings you need to show your verification of the result or of your code. I mean, in this manner you need to explain mathematically what is actually happening and verify that your code is actually working. Okay, even I think in midterm I mentioned it in most of the questions, but even if I forget to mention, it is your responsibility to justify your code by showing the mathematical calculations. Okay, in example 6.6, if any one of you have any question, you can ask now. But please make sure you understand this example. If you don't understand this example, it will be very difficult for you.
Sir, can you, I understood it, but sir, can you tell again why the carry, how the carry becomes from 0 to 1?
Yeah, you are talking about this
Yeah,
carry
this,
from
this line exactly, sir.
this is actually the step of sub. I mean, this is the process what will happen within the mu c. So the step says at the end you have to invert the carry. So that's why I inverted the carry. I am not going for any logic or something like that. If I write sub, these are the 3 steps that will happen. So I have simply executed those 3 steps.
So this is just a process, part of the process.
Exactly the process. Yeah. Anything else? Any other question? Anyone? All right, so let's move on. We finished what will happen if carry is equal to 0. So let's see what will happen if carry is equal to 1. All right, so this is used for multiplied numbers. It will also be clear when we take an example. Things are best understood with an example. So let us see the example. Example, this is 6 to 7. Question says, so the question is subtract 1296 hex from 2762 hex. So let's see the solution. Okay, before we go for the solution, let us do the subtraction using our calculator and let's see what happens. So what we have, 2762H minus 1296H. Can anyone tell me what is the answer?
14CC.
14CC. All right. So this is the result that we expect, that we are supposed to get. So let's begin. First of all, we'll clear carry. Then we will move something to the accumulator. And after that, we will write sub a comma something. Can anyone tell me what will be the values in these two after these two hashtags? In the first one, move a comma hash. Then what should we write?
2762H.
That's why I asked you the question. Your accumulator is an 8-bit register, right? So think carefully. What should we move?
2x.
Again, I couldn't hear.
6 to 8.
6 to 8, exactly. So we start with 6 to 8. That is the lower byte of the first number. And then sub a comma. How much?
96.
968. Okay. So if we do this thing, so tell me what is the binary of 62? You know what? Forget about binary. Let's do it directly in hex. So 62H minus 96H. What is your result? If we subtract, what is the result? Give me the normal answer in hex. Yeah.
So double C.
Double C. So your accumulator will contain double C hex. Is there anything else, or is it only double C?
Sir, FFF double C.
If that means your carry will become 1. Is it understood up to this? After you execute these two lines, your register A will contain, or your accumulator will contain CCH, and the value of carry flag will be 1. Is it clear up to this? If you don't understand up to this, it will be difficult for you to understand later on. Have you understood?
Yes, sir.
So see, we have already got one part of our answer, that is CC. So we need to store this result, right? So we can use any register to store the result. So let us write move R7, A, where we where we store our result. After that, again we need to load the accumulator register. So now we will load 27 hex, and then we'll write sub a comma 12h. So when I write sub a comma 12h, what will actually happen? It will be like 27h minus 12h, and this carry will also be subtracted. So minus 1. How much do you get?
14.
Exactly, 14h. So see, we have got the second part of our result. So now we need to store this result. So you can use any register. So move R6 comma A. Thus your result is stored in R6 and R7. These two will give you combinedly 14 CCX. So that's why I told you that this is used for multi-byte numbers, because we can only perform subtraction using 8-bit registers, right? So what will happen if there is a carry from here to here? So to accommodate that carry, we need this sub, which will be accommodated by this carry flag. Any question up to this? Anyone, any question? Okay. So if you do not ask anything, either you have understood everything or you have not understood anything at all.
Sir, the question, sir. Sir, if the carry is 1 in the last,
Exactly, that is the
in the
question
end.
I was expecting. Yeah, I got your answer.
So
I
we
got
have
your
to
question.
complement it like R6 and R7, then add with 1 and like to complement, right?
What you can do is, see, if the result is negative, you can simply write that the stored result in R6 and R7 is in 2's complement of the original result. That much is enough. Because if there is someone who knows that this is in 2's complement, I believe that he can always execute these two lines to find out the 2's complement. So if there is a carry at the last, definitely the answer is in 2's complement. So you will simply write that the answer is in 2's complement. Okay?
Okay, sir.
Okay, any other question, anyone? So let's move forward. I think this is pretty straightforward. Whatever is written in front of you, go through the example and just tell me what will be there in B and what will be there in A. You can take your time, you can finish writing, then you can do the calculation.
Is it something like this, that B will hold a 99 and A will hold 0E?
B will hold 99 and A
0E.
0A.
Sir,
Yeah.
reverse will be.
Not reverse. This one is the right one. See, B contains the upper byte and A contains the lower byte. So I think this is the upper byte and this is the lower byte, isn't it?
No, sir. The upper byte is
No,
0E.
sir.
And lower byte is.
0 is
It will be the reverse, yeah.
It will be the reverse actually. So B will contain 0EH and A will contain 99H. So understood, all of you? Is it clear to all of you? Anything you want me to explain over here? It's pretty straightforward and very easy actually. So now let us go for division.
What if the result doesn't consist in the two register A and B? If it overflows the registers?
Is it actually possible? What are the largest two numbers you can have? FF and FF, right?
Yes, sir.
So if you multiply FF and FF, what is the result you get?
Highest possible in upper byte is FE.
Hmm?
The result is FE01.
Result is FE01, right?
Yes, sir.
So is it possible to have overflow?
Yes, sir.
So see, so you don't have to worry about overflow. Clear?
Sir.
Follow. I can't hear. Say, volume come on.
Sir,
Yeah, say.
can we use other registers others than A and B?
No. You cannot use. For multiplication and division, it has to be A and B. You cannot use any other register or memory location or that value. Nothing is possible. Yeah. Any other question, anyone?
Okay, sir, what about whenever we have more than 8 bits?
If you have more than 8 bit, like this one, then you need to break the number, then put it in A and B and do the calculation. That is something you have to devise on your own, okay? That is logic building.
Okay, sir.
Okay, good question. So keep that in mind, okay? You might face questions like that, so you should know how to do that. Yeah, now let us move on to division. The things that you will see, I mean, after me that we will learn now is I will only touch the basics. I will not go in deep details. So logic building and problem solving, all of those things will be totally upon you. So please understand these logics carefully. I mean, understand these basics carefully. Okay, so after this division, tell me what is there in A and what is there in B?
Nine.
Nine is where? A or B? A?
9 in A, sir.
Yes, sir. 9 in 8.
A. And what will be there in B?
5.
Exactly 5. So this is the quotient, and this is the remainder. Now there is something that you should know about flag. That is if denominator, that is your register B, is 0, then your carry will be 0 and overflow will be 1. What this means is that, see, whenever we perform divide AB or division AB, we perform this thing A by B. So that means when you are performing A by B, if at any instance you divide any number with 0, the result is infinity, right? So to show this result as infinity, your overflow flag becomes 1. If in any case your denominator or your register B becomes 0. But if your register B is not 0, then your carry and overflow will always remain 0, because you will always get a result. Doesn't matter what, but you will always get a result. You will only get an error or unexpected result if your denominator becomes 0. So this is something you should remember about your carry flag. Clear up to this? Now we'll see an example. But anyway, if you have any question up to this, you can ask.
Sir, in the case of error, what will be the value of A and B? Will they retain their original values?
I have actually not tried that. I don't know. So you can try it on your own. That's a good question, actually, valid question. But you know, we don't have any software like the emulator that we had in our previous course. So in that software we could have verified, but in this case I don't think we can verify. So in order to verify, we have to get back to emulator 8086, because over here the one that we have is MIDE and Proteus, so we cannot verify the result using these two softwares, isn't it?
Yes, sir.
So I actually don't know what will be there in A and B. All right, so let us see an example now. Example 6.9. This is a good example because this is quite universal. Okay, unique. This is how do you convert from hexadecimal to decimal. Before we go for the solution, let us do it on our own. If we are given any hexadecimal number, say the number we are given is 9CH. How do you convert to decimal using the division process? How do you do it? Without going to binary or anything, directly from hexadecimal to decimal. Say again.
Sir, 16 to the power 0 plus 16 to the power 1.
No, not that one. I am asking the process of division.
Divide by 16.
Divide by 16. We are going from hexadecimal to decimal, remember.
Multiply by 16.
Okay, let's take a decimal to binary. Wait, decimal to binary, okay? So I have a decimal number of 12. How do you convert that to binary using the division process?
So divided by 2.
Divided by 2.
Exactly, divided by 2. Why? Because we are going to binary. That is the base is 2. Now we are going from hexadecimal to decimal. So what is the base?
10.
10. So what is the equivalent of 10 in hexadecimal format? Because we have to divide in hexadecimal, right? So what is the equivalent of 10?
A.
A.
Exactly. So we need to divide it by A. Come on. You should know this thing by this time. So if you divide A, if you divide 9CH with A, what is the quotient and what is the remainder? Quick, be quick. By this time, you should be very quick about this thing. Otherwise, you will feel that, sir, the time in the semester final is very less. Okay, so be quick. What is the question and what is the remainder? ক্যালকুলেটরে তো দিয়ে দেয়, এটা করতে এতক্ষণ লাগে, আমার তো হয়ে গেল অলরেডি।
Quotient is F.
Quotient is F, right? Then what is the remainder?
Is it 8D?
How much?
Sir,
Remainder is 6.
The remainder is 6, exactly. Now divide it again with A. What is the quotient?
1.
1. What is the remainder?
Sir, 5.
5. This is already less than A, so we don't need to divide that again. So 9CH, if you convert to decimal, how much do you get? Come on, from here, the answer is already here. How much?
156.
156.
Exactly, 156. So this is the step, right? So this is now, once you know this step, coding becomes very easy, right? So you already know. So now look at the solution, it will be very easy. So first of all, we'll move this number, that is the number which is given to us, 9CH in the register A. And we know that for division, we need to use A and B. So we have to move the other number in B, which is 0A. Now we will divide AB, simple. And we know that your A contains the quotient and B contains the remainder. And we need to store this 6, right? So you can use any register and store this 6 because it will be again overwritten from B. So use any register and store. So now your R0 contains 6. And your after this first division, your A contains this quotient. So A contains F. But B has been changed to 6. So we need to load B once again. So move B 0AH. So we have loaded B. So now we need to divide again. So if I divide again, now I know that B contains 5 and A contains 1. So simply move the contents of B1 to another register, R1. So that means R1 now contains 5. And move the contents of A to R2. So now R2 contains 1. Thus you can say that R2, R1 and R0 contains my result. Is it okay now? Have you understood? And you need to specify which one is your MSB or not MSB, which one is the lowest digit and which one is the highest digit. So you can simply write R0 contains the lowest digit and R2 contains the highest digit. This is actually a universal code. If you are given any type of hexadecimal number, of course in byte sized, you can simply write that hexadecimal number over here. The rest of the things in the code will remain as it is. But if you want, you can change these registers. That is totally up to you. Have you understood? Any question over here up to this?
Why did we divide by A? Can you explain it again?
All right. So it depends in which format we are going. If you are going to decimal, you need to divide by 10. But you are having a hexadecimal number. So dividing by 10 means you need to know the equivalent of hexadecimal in 10 because 10 in hexadecimal is actually 16, right? So that's why we need to know the equivalent of 10 in hexadecimal, which is A. Similarly, if you go to binary, we need to divide by 2. So if you go to hexadecimal, we need to divide by 16. All these things were discussed in chapter 0. So you can review chapter 0 once again if you want. Any other question, anyone? All right, so if there are no other questions, then I think we have completed addition, subtraction, division, and multiplication of our unsigned numbers. So now it's time we move on to signed numbers. Okay. So this is your 8 bits or a byte-sized number. It is very important that all of you must always remember which one is which digit or which bit. Like this is your D1, sorry, D0, D1, D2, D3, D4, D5, D6, and D7. When we are talking about signed numbers, it means that this one, I mean, this bit only, D7, will be responsible for representing the sign. The rest of the digits that you have will simply represent the magnitude of the number when we are going for signed numbers. Okay, be it positive or negative. This bit or this digit, that is D7, will always be kept aside for representing only the sign of the number. The rest of the digits will represent the magnitude of the number. So if that is the case, tell me in signed bit operands, what is the largest positive number that you can show or you can store? What is the largest positive number? How much?
127.
Exactly. The largest positive number is 127 that you can represent when you are having signed bit operands. Okay. So if we have a positive number, there is nothing to worry about. But things get complicated when we have a negative number, as you have seen at the beginning of today's class. Okay. So let's see what will happen when you have negative numbers. Let me go to the next page. All right, so this is not something that you have to do. This is something your MUSE automatically does, but at least you should know what your MUSE is doing. Okay, I'll give you some example. It will be clearer then. So let's see an example. So if your MUSE encounters questions like this or problems like this that add plus 37 and minus 115, now let us try to see what your MUSE will do. Okay. So first of all, let us do it in normal process. So we have plus 37 and minus 115. What is the result that you expect? What is the result that you expect?
78.
78 or minus 78?
Minus 78.
Minus 78. Okay. So if we have a positive number, we don't have a problem with that. So if you convert the positive number to binary, how much do you get? 37, convert 37 to binary. How much do you get?
00100101.
00100101, right? Now comes what will happen if we have a negative number. Now we'll follow these three steps. The first thing is write the magnitude of the number in 8-bit. Forget about the sign. So if you convert only 115 into binary, how much do you get? Tell me. How much do you get if you convert 115 only to binary? 0 111 right? So this was our first step. Write the magnitude of the number in 8-bit binary. So I've written. What is the next step? Invert each bit, right? So let us invert each bit. So if we invert each bit, we end up getting 1 0 0 0 1 1 0 0, and finally we have to add another 1. So if we add another 1, how much do we get? Adding 1 will bring no change in the upper nibble. The lower nibble will become 1 0 0 1 1 0 1, and this 137 will remain as it is. There will be no change. So it will be 0 0 1 0 and 0 1 0 1. So now you perform simple addition. So if you simply perform the addition, 1 plus 1 is 0, 1 is carried out. Again, 1 plus 1 is 0, 1 is carried, 1 plus 1 is 0, carried, okay, 1, then okay, no carrying, and finally 1. So now tell me, what is the hexadecimal equivalent of this number?
E2, sir.
Exactly. This is the result that you get. So these are the 3 steps that happens when you have a negative number. If you have any question now, you can ask.
Sir, isn't step 2 and 3 just making 2's complement of the
Exactly. Yeah,
subtrahend?
of course. Yeah, it's of course making 2's complement, nothing else. Any other question, anyone? If there is no question, solve this one and tell me what is the answer. Solve B and tell me what is the answer. Do it, come on. How much?
866.
86H.
Hex.
86 hex. 86 hex. This one? Anyone with any other answer, or you agree with this one?
Sir, 7A.
7A. Okay, let's see. Any other answer?
Sir, F86H.
Here 868. Okay, let me tell you, I have not yet received the right answer.
Sir, 106H.
106. Not yet the right answer.
Sir, 186.
Not yet the right. I'll stop writing. Okay, now let's see if I can get the right answer.
Sir, FA.
No,
Sir, 185.
no. Let me give you a hint. You see both the numbers are negative, right? So that means you need to perform all these 3 steps for both the numbers. Now try again. Oh, sorry. I think I have got the right answer actually. Wait, because I have written something wrong. Wait, I have given -33, -79, right? Yeah, I think I have got the right answer. This is actually the right answer. Sorry. I've written 79. In the book, it is 78. So I was looking for 78. The right answer is 86H. Sorry for that.
Sir, will there not be an F because the answer is negative?
There will be a carry. Yeah, there will be a carry, but you will neglect the carry. The result will be stored in a 8-bit register. So you will neglect the carry and only the register. I mean, the 8-bit will be your result. Okay. Okay, whoever said 86, thank you. Okay, I misread it. Do I need to show the calculation for this thing, or is it clear to all of you? So the numbers we have got are -43 and -79. So tell me, what is the binary of 43?
0 0 1
0
0
0010
1 0 1 1.
111011. After finding the binary, we need to invert each bit, right? So it becomes 1101 0100. After that, we need to add 1. So if we add 1, how much do we get? We get 1101 0101, right? Clear up to this?
Yes, sir.
So do the same thing for 79. So if you convert 79 into binary, how much do you get?
0100.
0100, then
41. 4 ones.
4 ones. Okay. Now invert each bit. So it becomes 1011. Now add another 1. So it becomes 10110001, right?
Yes.
Isn't it?
Yes, sir.
Now do the calculation. 1 plus 1 is 0. 1 1 0. 1 plus 1 is 0. 1 plus 1 is again 0. 1 1 plus 1 is 0 and 1. Right? This is the answer. Is my calculation okay?
Yes, sir.
All right. So forget about the carry. What is the equivalent of this one?
Or 186.
Sir, I think you have missed one thing. It should be 1100.
So the upper by
Yes,
2
sir.
should be 1000.
Yeah.
Which one? Which
The
one?
result. The
Yes,
result,
sir.
sir. The upper by of
result.
the result.
Oh, yeah, that's what
One-
I was saying. That is my calculation okay? It's 0, 1 plus 1 is
After the carry, yes, it should be 1000.
Sir, after the carry 1000, then 0110.
After the carry 1
000.
000 and
Yes,
then
sir. It's
0,
okay.
1, 1,
It's
0,
okay.
right?
Rest of it,
It's okay there.
sir.
Okay. If this one is okay, now convert this to hexadecimal and tell me how much is it?
186.
186H.
186.
Yes, sir.
Just a second.
It's 86.
Exactly. It's not 186. It is 86H.
Only 86.
Yeah, this one is for sign. I told you this one will go for carry. So forget about the carry. The result is 86. Is it understood now?
Yes, sir.
No, sir.
Which one you did not understand? Simply
Sir.
use your calculator. Convert this to heads.
Yes, sir. After converted it, I got 186.
You will convert only this much. This much. Okay. Let me do only this much. Do again. I have also converted it just now. You should get only 86H, not 186. Have you found it?
Yes, sir. It's okay now. Thank you.
Okay now?
Okay.
Alright, so only the last topic left for today's class, that is our overflow problem. Okay, let me go to the page. Alright, so based on the given logics that you can see in front of you. For example 1, tell me what will be the value of overflow flag. Will it be 1 or 0?
So it will be 1, sir.
It will be 1. Anyone else with any other opinion? Okay, so let's take another example.
Sorry,
Add-
sir. It will be 0, sir. Sorry.
Okay. Now let us go for another example. Okay, add -2 and -5. So in this one, tell me what will be the value of overflow flag. So I have given two problems. So tell me the overflow flag status of both the problems. $1058. Are you there? 1058, Shahid. Are you there?
Yes, sir.
So can you tell me what will be the overflow flag in the first example?
Sir, 0.
0. Why 0?
Sir, there is no carry out.
Here is no carry out. Are you sure there is no carry out?
Yes, sir.
Right. 1068 for them.
Yes, sir.
So what is your opinion? Overflow will be 1 or 0 in the first example.
Sir, I think it's 0.
0.
Yes, sir.
Right. 77. Samir কি হবে?
Sir, sure na sir.
Sure. Come on, everything is written in front of you. Still, if you get confused,
Sir, 1 হবে overflow.
1 হবে কেন?
Sir, second, they carry হইছে একটা D7 এ।
Exactly, there is a carry. I have not written that doesn't mean there is no carry. I have only showed you the result in 8-bit size, right? See
Yes,
the
sir.
calculation for yourself. The last one is 1 plus 1, so it can never be 0 over here. Of course, there is a carry. So there is a carry out, but there is no carry in. So which condition is being satisfied? Condition 1 or 2?
The second condition.
So second condition is being satisfied. So overflow will definitely be 1. Clear to all of you? Have you understood?
Yes, sir.
Now, can you tell me what will be the overflow for the second example? -2 and -5.
Sir,
What-
0.
Overflow will be 0. Anyone with a different answer? Okay, how did you find 0? Tell me. Give me your logic.
Sir, there was a carry from D6 to D7, and there was a carry from D7 out of D7. So
There was a carry in and there was a carry out as well, right?
yes, sir.
Yes. For this one, the overflow will be 0 because none of this condition is actually satisfied for the second one. So is it okay to all of you? Have you understood the overflow problem? Based on these two logic, if any of these two conditions is met, you will state the overflow to be 1. If none of the condition is satisfied, then the value of overflow will be 0. We still have a lot of chapter 6 to finish. Inshallah, we'll finish it in the next class. But this was all for today. Now regarding your attendance,